mga Batang MANDunong! Welcome back to Project SOAR, series of online academic review of mathematics CLAID learning module. I am Teacher Jessa, a teacher from Andres Bonifacio Integrated School, and I will be your moderator for Quarter 2, Week 3 of Project SOAR. Bago tayo magsimula sa ating pag-advance lesson, inaanyayahan ko ang lahat na i-share ang live video na ito. Huwag din kalimutang i-like ang aming official Facebook page, Math Team, Mathematics Teachers Association of Mandaluyong, at mag-subscribe sa aming official YouTube channel, MTM Channel. Mga Batang MANDunong at mga home learning partners, kanina ay nagkaroon tayo ng pag-advance lesson para sa Grade 7, Grade 8, at Grade 9. Ngayon naman, tunghayan natin ng pag-advance lesson para sa Quarter 2, Week 3 ng Grade 10. To introduce to you our reviewer, she graduated with Bachelor of Secondary Education major in Mathematics and minor in English at St. Columbian College, Lingayen, Pangasinan. She also graduated with 2 vocational courses, Information Technology and Computer Hardware Services at Mandaluyong Manpower and Technical Vocational Training Center. She is formerly an MTech trainer. What are we all waiting for? Let us all welcome Miss Nora M. Ramirez.
A pleasant morning, parents, teachers, and learners. Welcome to our Project SOAR, series of online academic review of Mathematics CLAID learning modules. I am Nora M. Ramirez, a teacher from Andres Bonifacio Integrated School. I made this review for the 3rd week of Grade 10 Mathematics.
Hello students! Today I am assigned to discuss one of the topics in Project SOAR for your reference in the 3rd week of Mathematics 10. This lesson derives inductively the relations among chords, arcs, central angles, and inscribed angles. Here are our objectives. Number 1. Find the measure of arcs and angles in a circle. Number 2. Find the area of the sector of a circle. Number 3. Find the area of the segment of a circle. Number 4. Find the chord and arc length. And last but not least, number 5. Describe and find the measure of an inscribed angle. Let us recall how the circle is defined. It is the set of all points in a plane that are equidistant from a fixed point called the center. The name of the circle is always the letter in the center. Now let's define each term. Line segment AJ is called the radius. The segment from the center to the point of the circle is the radius of the circle. Now, line segment AE is also a radius. Line segment FD is called the chord. A chord is a segment whose endpoints are at the 2 points of the circle. Line CK is also a chord. Now, line segment BJ is called the diameter. A diameter is a chord that passes through the center of a circle. It is also the longest chord. Now, line FH is called the tangent. A tangent intersects the circle at exactly only 1 point. Now, line CK. Line CK is called a secant. A secant is a line that contains a chord and intersects the circle at 2 points. Arc BAE is called the central angle. A central angle is an angle formed by 2 rays whose vertex is at the center of the circle. Next, arc BE is called a minor arc. A minor arc is an arc that measures less than a semicircle. Arc BDE is called a major arc. A major arc is an arc that measures greater than a semicircle. Take note that major arcs and semicircles are named with 3 points, and minor arcs are named with 2. Next, arc BCJ is a semicircle. A semicircle is an arc measuring 1/2 of the circumference of a circle, also known as 180 degrees. Now let's move on to the measures of central angles and intercepted arcs. The measure of the central angle is equal to the measure of its intercepted arc. Let's follow up to the example. The measure of angle RQS is equal to 100. The measure of arc RS is also equal to 100, since it is congruent to its central angle. Now, the measure of RTS is equal to 360 degrees minus the measure of arc RS. So 360 degrees minus 100 is equal to 260 degrees. Next, we will be discussing the arc addition postulate. The arc addition postulate is the measure of an arc formed by two adjacent non-overlapping arcs and is the sum of the measures of the two arcs. So sa Tagalog, ito ang kabuuan ng sukat ng dalawang magkatabi na arc. For example, measure of arc IK, ito, is equal to the measure of arc IJ and the measure of arc JK. So if we plug it in, the measure of IJ is equal to 41 degrees and the measure of arc JK is equal to 89. So if we add those, we get the measure of arc IK, which is 130 degrees. Okay, now let's talk about the area of a sector, where A is the area of the sector, C is the measure of the central angle, and R is equal to radius. A sector of a circle is a region bounded by two radii and an arc of a circle. The area of a sector is a fractional part of the area of the entire circle. This area is like a slice of pizza or a piece of pie. The value or the measure of it depends on how big you cut it. Now, this is the formula. The area of a sector is equal to the measure of the central angle over 360 degrees multiplied by pi r squared, or the area of the circle. Also, take note that this area is proportional to the central angle. In other words, the bigger the central angle, the larger is the area of the sector. Now let's find the area of sector CDE. Here is the formula I've discussed earlier on. The area of a sector is equal to the measure of the central angle over 360 degrees multiplied by pi r squared. Now let's plug in the values. For the measure of the central angle, it is 70 degrees, and for the radius, it is 6 centimeters. Now if you calculate that, it will be approximately 21.99 square centimeters, rounded off to the nearest hundreds. Now, let's talk about the area of a segment. The segment of a circle is the region bounded by an arc and the segment, which is the chord, joining its endpoints. To find the area of the segment of a circle, we have 3 steps. Step 1, find the area of the sector, which is this, the pie slice. Step 2, find the area of the triangle. And step 3, subtract the area of the sector with the area of the triangle. Now, let's find the area of the segment, shall we? This is the formula earlier. Now let's plug it in. The central angle is 60 degrees and the radius is 5. If you calculate that, the area of the sector is approximately 13.09 square inches. Step 2. Finding the area of the triangle. In finding the area of the triangle, this is our formula. The formula we use is half the product of the square of the radius and sine theta. If we convert it into the values, the theta measures 60 degrees and the radius is equal to 5 inches. Now, if we calculate that, the area of the triangle is approximately 10.83 square inches. Now, step 3. Subtract the area of the sector with the area of the triangle. So this is the formula. So the area of the segment is equal to 13.09 minus 10.83. The area of the segment is approximately 2.26 square inches. The chord. In other words, it's the distance from one point of the circle to another, or just a portion of the circumference. Now, let's move on to letter A, given the radius and the central angle. Here is our formula, where r is the radius of the circle, and c is the angle from the center of the circle to the points of the chord, and sine is the sine function. To read the entire formula, its chord length is equal to twice the radius times the sine of half the angle. Now let's move on to our example. Let us find the length of chord EA. Now, we can calculate the length of any chord if we know the angle measure and the length of the radius, because each endpoint of the chord is on the circle. The distance from the center to E and to A is the same as the radius length. Next, if we bisect the angle bisector must be perpendicular to the chord and bisect it. This forms a right triangle. We can now use a simple sine ratio to find half the measure of the chord and double the result to find the entire length of the chord. Now, let's input the values. For the radius, we have 10 centimeters, and for the central angle, we have 120 degrees. Now, if we calculate that, chord EA is approximately 17.32 centimeters. We've finished letter A, let's head on straight to letter B. It is given the radius and the distance to the center. This is our formula, where r is the radius of the circle and d is the perpendicular distance from the chord to the circle center. To read the whole formula, its chord length equal to 2 and the square root of r squared subtracted by b squared. Now, I want you to draw a segment perpendicular to the chord from the center, and this line will bisect the chord. Setting up the Pythagorean theorem with the radius as the hypotenuse and the distance as one of the legs, we solve for the other leg. And since this leg was half of the chord, the total chord length is 2 times of that. Now, we're going to plug in the values with 7 as the radius and 4 as the distance. If we calculate that, chord DN is approximately 11.49 centimeters. Now the length of an arc. The length of an arc can be determined by using the proportion where A is the degree measure of the arc, R is the radius of the circle, and L is the R length. This formula can be read by the degree measure of the arc over 360 degrees is equal to the arc length over 2 pi r, also known as the circumference of the circle. So how do we calculate this? What we discovered is that the length of an arc of a circle is proportional to the measure of its central angle. Take note that the measure of the whole circle is 360 degrees, while 2 pi r is just the circumference. Here we have our sample problem. An arc of a circle measures 85 degrees. If the radius of the circle is 9 centimeters, what is the length of the arc? Let's bring up our formula. So since A is the degree measure of the arc, its value is 85 degrees. R is the radius, so we now have 9 centimeters. And L is the arc length, so this is what we need to figure out. Now, by plugging in RA is 85 degrees, R is 9 centimeters. Now, we must reduce 85 degrees over 360 degrees to the lowest term by simply dividing both numbers by 5. And the result will be 17 over 72. The ratio of 17 and 72 is equal to the ratio of the arc length, L, and the circumference of the circle, which is 18 pi. By cross-multiplying, the product of 17 and 18 pi is equal to the product of 72 and the arc length of a circle. And this will be divided by 72 on both sides of the equation to get the value of L, or the arc length. Thus, we have arc length is approximately 13.35 centimeters. Now let's talk about the measure of an inscribed angle. An inscribed angle is an angle whose vertex, or the intersecting lines, is on a circle, and whose sides contain chords of a circle. In the inscribed angle, the vertex should always be on the circle, because if it's on the center, it will be a central angle. Now, the measure of an inscribed angle is half the measure of its intercepted arc, meaning the measure of angle CAB is only half of arc CB. So if you have, let's say, 50 sa A, magiging 100 siya dito sa arc. And kung may 100 ka sa arc, magiging 50 siya sa A. In our first example, arc LM is 110 degrees. Now to get the measure of angle LKM, we must divide it by 2. So 110 divided by 2 is equal to 55. Therefore, the measure of angle LKM is equal to 55 degrees. Now we must do vice versa on example number 2. Proceeding to the second example, our given is angle VXW, which is equal to 32 degrees. Now we must multiply it by 2 to get the measure of arc VW. So 32 times 2 is equal to 64. Therefore, the measure of arc VW is equal to 64 degrees. Now, I am going to explain that we need to find the measure of angle B that intercepts arc DC. So here are our given. The measure of B, the measure of angle B, is equal to 180 minus the measure of arc, the measure of angle D, and the measure of angle C. So getting the values, the angle D is equal to 49 and angle C is equal to 70. Meaning, the measure of angle B is equal to 61. But we still need to find the arc DC. So to get that, we multiply 61 by 2 to get 122 degrees. Okay, now in our fourth example, we need to find x. So here is our formula. The measure of angle EGF is equal to 1/2 of the measure of arc EF, which is 192 degrees. So here is it when our values are plugged in. 31x plus 3 is equal to 1/2 multiplied to 192. So 31x plus 3 is equal to 96. And then we need to transpose 3 to beside 96. So if we transpose positive 3, it will become negative 3. So 96 minus 3 equals 93. So 31x is equal to 93. Now we must divide both numbers by 31, leaving x, and 93 divided by 31 is equal to 3. So x is equal to 3. Now that we have finished discussing the lesson, let us have a short summary. A circle is a set of all points equidistant to a fixed point called the center. The letter at the center will always be the name of the circle. For example, A is at the center of the circle. The circle will be automatically named Circle A. Now let us have all of the factors to consider in the circle. First is the radius. A radius is a segment whose endpoints are the center of the circle and a point on the circle. A chord is a segment whose endpoints are 2 points on a circle. A diameter is a chord that passes through the center of a circle. This is also the longest chord, and it creates the semicircle, which is 180 degrees. A second is a line that intersects a circle at exactly 2 points. A second contains a chord of a circle. A tangent to a circle is a line coplanar with the circle, and it intersects it only once, only in one point. Now, the central angle is an angle formed by two rays whose vertex is the center of the circle. The inscribed angle is an angle whose vertex is on the circle and whose sides contains chords of a circle. A minor arc is an arc of a circle that measures less than a semicircle. A major arc is an arc of a circle whose measure is between 180 degrees and 360 degrees. A semicircle is an arc measuring 1/2 the circumference of a circle, or 180 degrees. This can be formed with the diameter. Now, the measure of the central angle is equal to the measure of its intercepted arc. Whenever you hear central angle, it will always be equal. The arc addition postulate is the measure of an arc formed by two adjacent non-overlapping arcs and is the sum of the measures of the two arcs. The measure of an inscribed angle is half the measure of its intercepted arc. Whenever you hear the word inscribed, it's always half and double. Next, we have the area of the sector. Its formula will always be the area of the sector is equal to the measure of the central angle over 360 degrees multiplied by pi r squared, or the area of the circle. The area of the segment has 3 steps. We need to find the area of the sector, triangle, and then subtract the both. Then, the length of the chord given the radius and the central angle. Here is its formula. The chord length is equal to 2r sine c2. And when given the radius and the perpendicular distance, the chord length is equal to 2 and the square root of r squared minus b squared. Now the length of an arc, where a is the degree measure of the arc over 360 degrees, is equal to the arc length over 2 pi r. And that is all. Happy learning, everyone, and thank you for listening to my lecture.
Thank you for listening. If you have questions, feel free to send a message to our official page, Math Team, Mathematics Teachers of Mandaluyong, or send a message to your mathematics teacher. This is Nora M. Ramirez saying, Math-sayang Math-aral, tayo na ang Math-tuto!